Hey guys, welcome to video lesson 3.4. 3.4 is called writing proportions. So unlike lesson 3.3 where we're just trying to figure out if the proportions are equal, in 3.4 we will be writing proportions. And the biggest difference here, which is part of our essential question, is can we use proportions to help us solve problems in real life. So an example I'm going to give you, hopefully a lot of you can relate. I'm baking a cake that requires 2 eggs, not 4. So for every 2 eggs, I will need 1 cup of flour. And I'm just making this up. This isn't a real recipe, so don't go off and try it. So I would like to know how many eggs, I'm going to use a variable. Notice what I'm asking you. How many eggs will I need for 3 cups of flour? So what we're going to do is just pretend that the x is a number. And if you recall from lesson 3.3, we just took each of the scenarios and wrote it as a ratio. Again, a ratio is a fancy word for fraction. So I'm going to take 2 over 1 and I'm going to set it equal to the second scenario. I'm going to set it equal to this. Is it equal to some number of eggs over 3 cups? So the 2 is eggs over cups. How many eggs to 3 cups? So to solve this, once again, the easiest way is to use the cross product. So 3 times 2 is 6. Oops. Is 6. And 1 times x is x. So that means these two solutions are equal to each other. So that means x is equal to 6. Let's just take a minute and go back to what we did in 3.3. Say I gave you 1/2 and 2 over 4. I know 2 times 2 is 4 and 1 times 4 is 4. These two answers, if they're the same, they're equal to each other. So in this example here on the left, I'm doing the same exact thing. I'm taking the cross product in one direction and I'm setting it equal to the cross product in the other direction. Let's try another example. I need 1.5 cups of black beans to 1 cup of tomato. So my question is, how many tomatoes, how many cups of tomato will I need for 6 cups of black beans? So all we need to do is write this as a ratio. 1.5 over 1. We took this first scenario up here and we're going to set it equal to this scenario here. So we're going to take 6 over x. Remember, the top number represents black beans, the bottom number represents tomato. So if I have 6 cups of black beans, how many tomatoes will I need? And the best way to solve is using the cross product. 6 times 1 is 6. 1.5 times x, well, 1.5 times something is 1.5 times something. This takes us back to skills we learned in chapter 2. The operation in here is times. To undo times, we're going to use division. So we're going to divide both sides by 1.5 because I'd like to isolate the variable. Cross these out, giving me x equals, take your calculator and punch in there 6 divided by 1.5 and you should get an answer of 4. So that means I will need 4 cups of tomatoes if I'm going to use 6 cups of black beans. All right, we're going to do one final example, and we'll call it quits. I have 5 over 8 is equal to 20 over D. And we can do this a couple of ways. When I look at this, I see 5 times 4 gives me 20. So I can simply do 8 times 4, which means D must equal 32. Right, the question or the problem comes up is if the numbers don't work out that evenly. So here's another way. 5 times 8 equals 20 over D. And we're going to use the cross product method like we did in the last example. What's 8 times 120? 8 times 20 is 160. 5 times D is 5D. We're going to take these two answers and set them equal. Now, if you take a look on the right, the operation in here is times. How do you undo times? We divide both sides by 5, so we isolate the variable. The 5's cancel. D equals, in your calculator, 160 divided by 5, I get an answer of 32. So in either way, you get the answer of 32. The second method is a lot longer. So if you have a way where you can use this example or this method from the left, you should use that way. All right, this is the end of video lesson 3.4. See you guys in class.